we have this nice equation. On the left hand side of this equation we have power towers of 2 and we want to find the value of x. So let's solve this equation. So if you look at here, on the left hand side we have 2 and then the power towers of 2. Since these are power towers, therefore we need to solve these powers downwards. I'm gonna show you in a moment what does this mean. So if you look at the left hand side of this equation, we have 2 here. So first of all, we would like to write 512 as the powers of 2. So how can we write 512 in terms of powers of 2? Let's make a tree diagram for 512. So we have 512. So if we make a tree diagram for 512, then we can write 512 as, so if you look at 512, then if we divide it by 2, then 2 2s are 4, 1 carries, so 2 2s are 4, and then we have 11 here, 2 5s are 10, carry 1, and 2 6 are 12. In other words, 512 divided by 2 is 256. Similarly, divide 256 by 2, then 2 ones are 2, sorry, 2 ones are 2, and then 2 2s are 4, carry 1, and then 2 8s are 16. 128 divided by 2 is 64, and 64 divided by 2 is 32, and if you continue like this, 32 divided by 2 is 16, and 16 divided by 2 is 8, 8 divided by 2 is 4, and 2 2s are 4. Now let's count the number of 2's. 1 2 3 4 5 6 7 8 and 9. So it means that on the left hand side, on the right hand side, 512 can be written as 2 times 9, 2 raised to the power 9, and then we have a power 9 again, and on the left hand side we will keep this guy as it is. So we have 2, then power tower 3, then a power 4, and then another power of x. So this is the power tower of 2. Now we will use this property on the right hand side, and that property says if you have some number a and you have some power of a, m power of a, and then you have another power n. So if you look at this guy is different than this guy because here you have parenthesis here. If you don't have parenthesis, it means that it is a power tower, so you need to solve it downwards. So you cannot just use this property that I am writing here. If you have parenthesis here, then that means just multiply these powers. So this guy is different than this guy, okay? But on the right hand side we can use this property. So this property says just multiply these exponents. So we have the base 2 and the exponents, just multiply these exponents. So 9 times 9 is 81, and on the left hand side we will keep this guy as it is, the power towers of 2. So 2 raised to the power 3, 3 raised to the power 4, and 4 raised to the power x. And now we can use this property. The property says that if you have a raised to the power some power equal to a raised to the another power, since the bases are same, so you can just cancel out these bases and the powers will be equal. So we can use this property, the bases are equal. So the bases are equal, so just cancel these bases. It means the exponents are equal. So 3 raised to the power 4 raised to the power x is equal to 81. If you look at here, the left hand side is the base on the left hand side is 3. So can we write 81 as some powers of 3? The answer is yes. 81 is 3 raised to the power 4, and the left hand side we will keep the left hand side as it is. 3 raised to the power 4 raised to the power x. Similarly, again use this property since the bases are equal, so cancel these bases. So the exponents must be equal. 4 raised to the power x is equal to 4, but 4 is equal to 4 raised to the power 1. And again use this property, the bases are equal, so the exponents must be equal. So it means that x is equal to 1. So this equation, the power towers of 2 on the left hand side we have, and the top power is x. This equation holds if x is equal to 1. So x equal to 1 is the only solution of this equation.